Hey guys, welcome to Pepcoding. Today we are going to learn a very interesting question. So basically we would be given an array. So array would be having few elements A, B, C, D, suppose like this. So let me write it. Suppose we have four elements A, B, C, D. This is 1 1 0 0 1 0 1 1 1 1 0 0 1 1 0 0 1 0, or let me just change it. We made it exactly same as A. 1 0 0 1 0 1. Suppose we have this array and we need to do what pairing. So we need to pair A B B C C D, then B A B C C D. What I'm saying is we need to pair two numbers. We take two numbers and we need to check how many bits are different between them. Okay, suppose for A we will take AB, AC, AD. Then for B, BA, BC, BD. Then for C, CA, CB, CD. Then DA, DB, DC. So total these many combinations would be made, and I'll check that in this, suppose in AB, how many bits are different. There is no difference, there is one difference. So 1, 2, 3. 3 bits are different. In AC, this is same, this is same, same, same. 1 bit is different. In AD, 1, this one, this one, this one, and this one. 3 bits are different. So similarly, I'll count for every pair and I'll sum them. The total sum would be my answer, that these many bits differ. Okay, so first of all, everyone can do this question with the brute force, which is I'll simply do it in O of n square. How will I do it? I'll run a for loop in array from 0 to n, then another for loop from 0 to n in it. Then I'll simply check the number of bits which are different in these two numbers, in array of I and in array of j. How will we do that? We all know that we'll simply perform XOR operation, and with the mask which will come, we'll simply count the number of set bits and I'll get my answer. This is the basic brute force. We have already done such kind of solution and I guess everyone will be able to do this. But let's discuss some optimized solution. Okay, let's optimize this solution. So I know that there are total number of 32 bits. Okay, how this information is useful for me, let's see. Okay, so just consider this bit at 0th bit, 0th position. So if you see, if I take number of set bits and number of unset bits, so set, unset. In set I have CD and here I have AB. Okay, so there are two in this, so what I'll do, 2 into 2 into 2. How this expression came, let me tell you. I can make pair if I need to count the number of change bits. So I can just simply take C and A, C and B. Okay, AC, BC. This and this. Two pairs are this. Okay, two pairs are AD, BD. This. So number of elements in unset into number of elements in set would give me two pairs. Then why I am using another two? See, if I get AB, then I am also getting BA. If I here, if I'm getting AC, I would be getting CA. If I'm getting AD, I would be getting DA. So every number would be coming two times because we are taking here permutations also. Okay, so this is why this solution I would be using 2 into 2 into 2. Let me show you for one more. Let's check this one. Here in set bit, I would be having A, B, C. In unset, I would be just simply having D. See, you can see that A is set, B is set, C is set, and D is set. Okay, so I'll pair D with A, B, and C. So 1 into 3, and then it could be like AD, BD, CD, then DA, DB, DC. So into 2. So this will finally give me solution. So let's do this. What I'm basically doing is I'm running a for loop for every bit. That would be 32 bits. Simple. And then simply taking account of set bits, unset bits, and I know the formula. Simply use that. So let's code this. Okay, first let me just take n as my array dot length, because this will help me later. I don't have to write again and again array dot length. So for the first check answer, that would be, we'll be returning in long answer equals 0. So int I equals 0, I less than 32, I plus plus. Here I'll take another variable count, y, which will count the number of unset bits. Okay, so when I'll get the number of unset bits, what I'll simply do is I'll simply uh, do the operation that was c into n minus c, because if there are c number of unset bits, there must be n minus c number of set bits, into 2, and I'll add it in my answer. Okay, not int, take it long. Why I am taking long? Because for some test cases it could be like 32 bits are different, so my count would be greater than that. So I should take long. There are total 32 bits. I am checking for every bit, and my answer could come in a really large value. So for to avoid such cases, let's use long. So for int j equals 0, j less than n, j plus plus. Run the for loop for every element in j. Now what I'll do, I'll simply check if my array of j. Now what do I need to do? If it's mask, suppose if I take the mask on that particular bit, on the ith bit, okay, and do perform the AND operation, then if I'm getting 0, that means that particular bit was off. Okay, unless if I am getting a non-zero value, it means it is on. So I'll check for unset bits only. So it's AND operation with 1, and we'll mask it I times because we need to check ith bit. So I'll left shift it I times. If it is equal to 0, in that case a bracket is missing. Yeah, if this is equal to 0, I'll simply increment my count, which is for unset bits. Then here I'll update my answer as count into total number of elements minus c. This will give me count of set bits, and finally multiplied by 2 and return the answer. So basically what I am doing here is I am checking for every particular bit. Line 13. Okay. This long C was declared, long answer was declared, int j less than n, j plus plus, array of j, 1 mask I equals 0. C might not be declared. Okay, equal 0. Yeah, it is accepted. Let's submit it. So all the test cases are passed. Let me in short tell you again. First I am running the loop for every particular bit. Then I am checking for all the elements how many elements have that particular bit unset. Then I am calculating the rest of the elements must be set. So unset, number of unset elements into number of set elements into 2, because permutations exist. Okay, and finally return the answer. So I hope guys this was clear to you. So please like, share and comment and subscribe to Pepcoding. Thanks for watching.